All right, so 11.4 was determining, excuse me, if a solid is a polyhedron, and then if it is, naming it, and then finding the number of faces, vertices, and edges, and then using Euler's theorem to verify it, which is F plus V equals E plus 2, faces plus vertices equals edges plus 2. So how do you know if something's a polyhedron or not?
When it's like, has sides, faces, edges.
What's true about those sides and faces? What can't they be?
They can be round.
Good. So like number 1,
That would be a circle.
it would be a sphere, but it's not a polyhedron, right? 2, is that a polyhedron? Yes. What is this one called? It's a square pyramid.
Wait, that doesn't make sense.
So it's a pyramid, yes, because there's one base. And that a pyramid is named by the shape of the base. The shape of that base is a square, okay? Which,
So if it was a pentagon pyramid?
correct. It would be pentagonal pyramid. Now we got to count, right? So it said to count the number of faces. 5, good. The number of vertices. 1, 2, 3, 4, 5, also 5. The edges. There is 1, 2, 3, 4, 5, 6, 7, 8. And we would verify that F plus V equals edges plus 2. So that's how you make sure you did it right. All right, then 3, 3, again, same set of instructions. What is this a polyhedron? Yes. What kind?
The pentagonal prism.
Good. Pentagonal prism. So prism because it has 2 bases, and then the shape of the base is a pentagon. That's the first part of its name. So the number of faces, the front and the back, 1, 2, 3, 4, 5, 6, 7 faces. Vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. And edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 17, and then 15 plus 2 is 17, again, to verify. Easy stuff, right? Questions on anything 11.4 related? Okay, so quick review of what we learned before now. 11.1 was our circumference, which is pi d, or 2 pi r. And then arc length, which is the measure of the arc over 360 times circumference, or times 2 pi r, or times pi d. All of those are interchangeable. Eleven two was area of a circle, which is pi r squared. And then area of a sector is the measure of the arc over 360 times either area or pi r squared, either of those.
What about the radians?
What do you mean?
The radians of the face.
We're going to do that too. Was that 11.1 or 2?
That's another one.
Right, okay. To go from radians, well, first we did degrees to radians. We took the angle and we multiplied it times pi over 180. And then radians to degrees, we took the angle and we multiplied it times 180 over pi. That was in 11.1. Then 11.2 had those two things. And that's what your quiz was on, was those two sections. Then in 11.3, we added the area of a rhombus or a kite, because they both have the same.
Wait, did we already graded this quiz?
Yes. Which is 1/2 times diagonal 1 times diagonal 2. And then we did the area of a regular polygon, which is 1/2 A N S or 1/2 A P, because N and S is the same thing as the perimeter. All right, and from those areas of the polygons, we had the ones that we had to use the calculator, like using SOHCAHTOA. Those will not be on your test. From the other ones where you have to use your special right triangles, that's where it's going to get pulled from. So you could still see a hexagon or an equilateral triangle from there. We'll get a little bit more practice before, obviously, your test. It's on the review. But that's what's from that section, okay? Your test is it's actually all multiple choice. And it's sometimes the answers you'll see are kept exact, and sometimes you'll use your calculator, but you'll have your calculator the whole time.
It's going to be till 11:40.
It's actually going to 11:06. So we're doing 11:05 today, and we're doing 11:06 tomorrow. Yep.
The test going to have 11:1 and 2 as well.
It's got everything that we just went over, and then 11:04, which was on the warm-up, to 11:06, which we're going to finish tomorrow. Okay? So we'll finish this. We'll do this again on Wednesday. And then on Wednesday, or actually by the end of tomorrow's notes, I'll publish a Quizlet that has all that stuff on there too. I don't want to do it yet because there's stuff we haven't learned yet, but I would say if you're a flashcard person, there's a lot of formulas this time. If you're not, then feel free to ignore it. All right, second to last section, 11:5. So this is volume of prisms and volumes and surface areas of cylinders is what's in this section. We're going to actually save the surface area of the cylinders for after the test. So we'll do all the volumes first. You'll take your test, and then we'll come back and do the surface areas.
Wait, so we're coming back to 11.
We're going to come back to just one slide on 11:5 next week. All right, so what is volume? The volume of a solid is the number of cubic units contained in its interior. So what do you fill it with?
Air.
No. The volume is measured in cubic units. So instead of area being like a centimeter squared, volume would be centimeters cubed or inches cubed. Cavalieri's principle says that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So if you were to just compare these two objects that are here, they're both prisms. One is a square or rectangular prism, and the other is what appears to be a rhombus, but it is at least a quadrilateral. If I look at their heights, which is top to bottom in this case, okay, but it has to be a right angle, so that's why it's drawn out on the right-hand side for the slanted one. If those heights are the same, and if I found the area of the cross-section, remember the cross-section is what shape is made when you slice this with a plane. So on the left, it looks like a rectangle. On the right, it looks like a parallelogram. If those are the same, then the volume of these two are the same. The first volume we're going to talk about is a prism. The volume of a prism has the formula with a capital B, and that capital is important. It is not lowercase b because it represents the area of the base. And then the H stands for height. If your base is a rectangle, like on the left, that's a rectangular prism. It doesn't matter which sides you pick as the base. You could do top and bottom. You could do right and left. You could do front or back. It doesn't always have to be sitting on the base. If they are rectangles, it doesn't matter. If the bases are anything other than a rectangle, so if this was a pentagonal prism or a right triangular prism, then it matters which sides you pick as the base. It would be the non-rectangular bases, okay? There is a shortcut for the rectangular. You don't have to learn this because you could figure it out the other way. But a rectangular prism, the volume is length times width times height. Because length times width gives you the base area. And if you multiply that times the height, you get the volume. But that only works for a rectangular prism. And the other one, you have to find the area of the base and multiply it times the height of the prism. All right, the second solid we're going to find the volume of is a cylinder. A cylinder is like a soup can, okay? It is like a prism, except the base is circular. A right cylinder has a segment that's joining the centers of the circular bases. That's an altitude, which means it is perpendicular. So this is a right cylinder because this is perpendicular to its base. If it was slanted, it would look a little bit like this. This would be a non-right cylinder. All right, the volume, actually we're going to come back to both the lateral area and the total area. You could write it out, but we're not going to apply it today. The lateral area is the non-base area. So the curved surface of your cylinder is 2 pi r h. The total or surface area is 2 pi r squared plus 2 pi r h. But again, we're going to come back. You can fill that in, but we're going to apply it next week because we're going to stick to the volumes. The volume of the cylinder is what you're going to practice today and will be included on Friday's test. And because the base area and the base is a circle, that B becomes 2 or pi r squared. So the volume of a cylinder is pi r squared h. You can remember BH, just to make sure you know that B is a circle, so it'd be pi r squared, or you can go straight to pi r squared h for a cylinder. Okay. So on the right cylinder on the left, you would need to know the radius, whatever this value is. If they gave you the diameter, you'd cut it in half. And you'd need to know the height of the can, sure. And then on the right, where it's not a right cylinder, so it's not straight up and down, you'd still have to know the radius, and then you'd have to be given this perpendicular height. So this no longer works for height because it's actually called slant height. That does not work the same. Yep.
So what would we do for that?
You do the same formula. It's just that the height is not the internal measurement. It's the outside measurement that they'll give you like this. All right, here we go. So we're going to find it in pieces. It says use the diagram to find, first of all, what shape is this? It's a cylinder. So B, capital B, represents the base area, which would be the circle. Good. Pi r squared, what's r? 5. And 5 squared would be? 25. So in exact form, because your test is going to kind of go back and forth, it would be that. 25 pi would be the answer, centimeters squared. And if it said to round, or if it had decimals in its answer, then I would have known I would have done 25 times pi in the calculator, which is 78.539. So if it was 2 decimal places, it would be 78.54.
What is LA?
LA is the lateral area. So this is the area around it. So actually, let's skip B and C for now because we're not going to do it.
Like on the test we're not doing it?
We're not doing lateral area or total area. We're saving it for after the test. The next round will be surface areas. This one's strictly volume of the prisms and cylinders and cones and pyramids. So volume, we could either do the base area times the height, or because it's a cylinder, we can do pi r squared h.
But see, we already have the base.
We already have that. 25 pi was the base area. What's the height? 7. So in exact format, that's 175 pi. And if I wanted the decimal, 549.78, and it would be centimeters cubed this time.
Is also 175 pi centimeters cubed.
Mm-hmm.
Why is it cubed?
Because it's volume. Volume is usually 3 measurements. With me so far? Okay, example 2, find the volume of a square prism that has a base edge length of 5 feet and height of 12. So a square prism, so if you want to give yourself the visual, I actually start with the base and then just draw back. So now the base for me is the front and the back because I made those the squares. If you made the tops and the bottoms the squares, then those would be the bases. So here's my bases. The base edge, it's a square, so they would all be the same, 5 and 5. And the height is the segment that connects those two bases, is 12. You can totally do a square rectangular prism without drawing it out because the volume would be length times width times height. In this case, our length and width are the same. So this is 5 times 5 times 12. Or 300 feet cubed. If you did it using the base area times the height, the base area would be 25 because it's a square, times the height is 12, and it still gives you the same answer. Good so far? Yep.
So the length is the same as the width?
For a square, it would be. Yeah. All right. Example 3 says find the volume of the puzzle piece shown in cubic units. See if you can do it yourself. And there's more than one way to split it. You can split it however you want, but obviously you need to split this into its parts.
You get a prize.
How many of you split it top and bottom, like across this way?
I think that's not bad.
How many of you split it this way?
I split it in.
Okay, interesting.
Invisible rectangle.
So you could do it either way. Okay, so if I did it this way, this top object is actually a cube, right? So length times width times height are all the same. 1 times 1 times 1 is 1 unit cubed for that top part. The bottom, my length is 3, my width is 1, my height is 2. So this is 6 units cubed, and then add those together, and it's 7 units cubed, okay? This was 2 rectangular prisms put together. Sometimes they'll take a rectangular prism and they'll top it with a cylinder, and you'd still have to find the areas and then add them together. Everybody still good? Okay. Example 4. The volume of a right cylinder is 684 pi cubic inches, and the height is 18 inches. Find the radius. So now we're working backwards. What's the formula for the volume of a right cylinder? Pi r squared height. Good. Or base area times height, but you got to break it down into its parts.
What was the answer to example 3?
7.
Oh my God.
So what's this measurement that they're giving you here? 684 pi cubic inches. What does that represent? That's the volume. So on the left goes 684 pi. On the right, pi stays as pi. Do I know R? Nope, that's what I want to try to find. Do I know H? It is
Yeah.
18. How do I work to find R? Jonathan.
Divide 684 by 18, that's r squared.
Okay, I could divide both of them by 18. 684 divided by 18. 38 pi equals pi r squared. And then
Then r squared equals 38.
we'll get rid of the pi first, right? Pi.
Go down.
Sorry, did you say please? I just didn't hear you.
Oh no, I was talking to Jonathan.
Oh, okay. You could still say please to him.
I know.
So I tend to get rid of the pi's at the beginning. The order you did that doesn't matter. But I tend to say if there's pi on both sides, I would divide by it from there and then divide by 18. But it still would give you the same answer. You could even divide by 18 pi, both of them together. And then r squared is 38. So r equals, if I wanted my answer kept exact, square root 38, which would be 219, and that goes nowhere. So that would actually be the simplest form if it wanted it exact. And then if it said to round it, or if your choices were rounded and you looked at your answers, I would do the square root of 38 in the calculator.
6.16.
Good. And it would be in inches if it had a unit.
Cube?
No, just inches because it's just the radius. So volume is cubed, area is squared, but every other length would be just the unit. Questions on that one? So with cylinder, you could work backwards to find the height. You could work backwards to find the radius. With a rectangle, with a prism, you could work backwards to find the base area or the height. All right, example 5. This is an oblique prism.
I've never seen a shape in my entire life.
Well, look at that. First time for everything. What's the formula for the volume of a prism?
Base times height.
Base area times height. What is the shape of the base? Triangle. Specifically, what kind of triangle? A right triangle. So if I want to find the area of that, 1/2 base times height, or capital B would be 1/2 base times height, which is 1/2 9 times 5, 45 over 2, which you can keep that way. Or you can make it 22.5 because that rounds to be an exact number. Either way. What's the height of the oblique prism? 8. It gives it 2 off. It's the one that's got that perpendicular segment. So this would be 22.5 times 8, or 45 over 2 times 8. You could do it either way. And that's 180 meters cubed. Questions on that one? All right, then we get to similar solids. So we have worked with similar polygons. We said if two objects were similar, then we used what was called the scale factor to find the ratio of their corresponding sides. That's the same for this. So these are two solids that have the same type, so they have to both be prisms or both be cylinders. They have to have equal ratios of the corresponding linear measures, which means the heights or the radii would have to be in proportions, okay? And then the ratio of the corresponding linear measures of the two similar solids is still called a scale factor. If two similar solids have a scale factor of k, then the ratio of their volumes is equal to k cubed. So if you go back to scale factor, let's say our scale factor is A to B, and I wanted to find the ratio of their areas. Do you remember how to find that? What'd you do the scale factor to find the ratio of their areas?
Times.
It's been a couple weeks. Something really sunk in. If the scale factor is A to B, then the ratio of the areas is A squared to B squared. And now we add the ratio of the volumes would be A cubed to B cubed. So if I told you the scale factor of one solid to the other was 2/3, what would be the ratio of their areas? Areas. 4/9. What would be the volume? Ratio of the volumes? From the initial one. Yep. What's 2 cubed? Oh boy, 8. 2 times 2 times 2. I heard like 7 different answers and I think they were all wrong. Nope. 3. Go back to 3. 3 cubed is 27. No, 3 times 3 times 3. So they could give you any of those 3. Like it could say, if this is the ratio of the areas, what's the scale factor? You work backwards. If this is the ratio of the volumes, then what's scale factor? You could work backwards, okay? One relates to the other. You'd have to cube root the last one to get to the first one. Or you could see it something like this. Prism C and prism D are similar. Find the volume of prism D. What piece of information do I know about C? Well, I know two things about C. Yeah. I know the side length and I know the volume, right? On prism D, you only know what? The side length, which is how you could get the scale factor. It doesn't matter what order you do this. If I did C to D or D to C, as long as I'm consistent. What would be the scale factor of prism C to prism D? 12 to 3, which becomes 4 to 1. That's the scale factor. What would be the ratio of their volumes? Mm-mm. 64 to, what's 1 times 1 times 1? 1. So the ratio of their volumes is 64 to 1. So if I have the volume of C, that's going to go on the top because I did that in that order. 1536 would go on the top, and the volume of D is what I'm missing. That's my X. Cross multiply, 64X would equal 1536, and then divide by 64. And X is 24. So the volume here would be 24 meters cubed. So if you're given the scale factor or you can find it, you're going to simplify it first. Always simplify it or your number's going to be huge. Simplify that and then set it equal to the ratio of the volumes. No, simplify it, then cube it, then set it equal to the ratio of the volumes, and then cross multiply and solve.
So there's two new theorems.
There's formulas, you mean?
Yeah.
There's the volume of the cylinder, the volume of the prism, and then the ratio of the similar solids. Yep, I would say 3 new things because we'll come back to the areas. Oh, actually, let me check that big idea to make sure that the areas aren't on it.